Well, hello there, YouTube. We're back with some more exciting build video action on this Airbus A380. Okay, so we've had this sitting for plenty of time. These things should be set up enough, but I'm always really nervous to take the tape off if it's even close to being premature. And we have another part of this project that needs to be dealt with, and that would be to go ahead and set up some of the EDF stuff, which is going to be fairly complicated. I don't want to lose anybody on this part, but it does have to happen, and it's going to be pretty cool. But just bear with me, guys. I'll try to make it as easy as possible, and there's nobody saying you have to do it the same exact way I do, unless you want it to be awesome like mine. So what we're going to do is we're going to set up the differential thrust. We're also going to make these servos come up to their home position, and we have to now also set up the power to the separate ESCs, because as you know, there's 4 ESCs. I have 2 batteries to simulate a 2-battery configuration. I also have 1 battery to simulate a 1-battery configuration. This is the actual battery, so we'll probably just use this one, which is a hybrid, not broken cells from three different batteries. It's kind of embarrassing. So in order to do this, we got to kind of flip things over. This would be a heck of a flying wing, wouldn't it? Be kind of cool. So basically, at this point, I need to separate all this crap and try to hook it up. So I'm going to get some side cutters, and the other thing is, as you're doing this stuff, just periodically double check and make sure you've got everything tight where you want it. So I'm going to get some side cutters. We can separate all this stuff, and these bundles of wires are going to have to be straightened out to at least some reason and logic, and we're going to probably zip tie the ESCs back into their places. Alright, normally I don't use these colored zip ties, but they can kind of work nice when you're talking about multiple electronics. You can help keep things straight. Basically, wires start tripping all over themselves and it gets complex. Just trying to keep things straight even though you know what you're doing. So I'm going to take this assembly apart. I've got a piece of wood that's in between these two. Okay. So there's your assembly. And they used a heat shrink to force these wires to not be able to come apart. Clip those off. Okay, so those can be used for another project somewhere. I just want to double check that none of this stuff is in bad repair. If it is, we can heat it up and try to slip it down. This would normally receive this cable here. You know, and I was talking about doing differential thrust, and I still plan on doing that. But I just want to talk to you guys, some of you naysayers that are concerned about having multiple BECs. That's the battery elimination circuit, or battery eliminator circuit. That's what this is. Right there it says the BEC, 5 volts at 3 amps. That's going to actually be on the back side of this board. The top side, there's a heat sink on top of a bunch of MOSFETs that are going to actually essentially take, and I know this is going to be a somewhat simplified version, but it's going to take DC and it's going to make it into an AC signal. And that AC, it's actually like a variable frequency drive sort of configuration. So the signal, which comes on the white wire here, and then the red and black wires, are power that's being fed back out to whatever this is hooked to. In our case, it would be a receiver. Now, there's some valid debate that is going on here. And the debate is as such. If we have a BEC, imagine it like a battery, even though it's actually a power supply, okay? If we take the positive and negative of those and we feed it into the receiver, then we have the signal wire, which is sort of indifferent at this point. Well, what happens when we take a second one in parallel and we feed into that same circuit? So all the reds and all the blacks are going to touch, right? Well, what some people are concerned about is that these guys are going to fight over the load that's generated by the receiver, the servo here, the servo there, the two servos that are driving, of course, the elevator, the rudder servo in my case. And what people argue is that when there's a load generated, none of these power supplies know which one is responsible to handle that load. I would say that they're pretty much going to handle the load evenly to a certain degree. And then people start going off into tangents about, well, what happens when you hit overload? When you get to the 3 amps at 5 volts, the total output of power that the battery elimination circuit can handle. Now, I can tell you this right now, guys. The battery elimination circuit is a separate circuit from the actual brushless circuit. Okay, I mean, yes, of course, there's common points where the main battery lead comes in, and there's going to be, of course, common traces on the board, but for all intents and purposes, they're two separate devices. The BEC, which is the stupidest name ever, should just be a voltage regulator, actually operates off the same battery voltage. In our case, we're going to have a little splitter or combiner that takes these and puts them together, so we can use a single LiPo. But for all intents and purposes, these things are all independently acting. And so some people are suggesting that you have to basically remove the signal wire on 3 of 4 of these ESCs, which would give you the ability of not having any arguments over who's going to carry the load. Problem with that, now the other option would be to use a UBC or an SBEC, a switching BEC. These are linear BECs. If you use an SBEC, it would be another device just like this that would tie in parallel to your battery input. Okay, so you would pull power from one or the other, or you would have hooked up to this cable, you would have power being pulled here. Okay, totally up to you guys how you want to do it. In my case, I am very tempted, seeing as the manufacturer has put them all together, to just go with it. Here's why. I want the 5 volts is going to be in parallel, so it's 5 volts. Okay, no matter how many of these you put in order. You put 100 of them in order, you're still going to get 5 volts. If they were in series, of course, if it was a battery, then you would have 5 added each time you put them in series. Well, this is a parallel, and it's a power supply. It wouldn't work the same way in series necessarily either. But on the current side, well, you're going to add that together in a parallel configuration. So if you have 3 amps plus 3 amps plus 3 amps plus 3 amps, that means 12 total amps of available power. However, these guys are going to fight when you start getting to the top of the range. I've never had a plane that gave me problems on anything greater than 5.5 volts at, I believe it was 4 or 5 amps. Either way, that's a lot of power, okay? In this case, I don't think we're going to have an issue. We only have 2 servos, 2 more servos, and then there'll be 2 servos for the rudder, okay? So we're going to end up with a total of 6 servos, and then later we're going to add 2 servos for flaps. So one thought I had was to ultimately take the power wire from this one, or this one, or this one, or this one, and run the ailerons. And then take the power from this one, which means that you still have to carry your ground back to the receiver where everything comes in and it's common, okay? But you can split off just the red wire, You still need the signal so you can tell the motor how much to move. But you take the red wire and then you go common back to the ground, and you can run the power as an individual circuit for these two. And then on this one, you'll run an individual circuit for these two. And on this one, we'll run an individual circuit for this and that. And on this one, we'll run the receiver. So that way you keep everything separate. In practice, it's a little bit harder. It's going to take a lot of wiring. It's going to be kind of confusing. If you're new to the hobby, it's probably just going to scare you off. So, I mean, I don't want to discourage anybody from trying this. But at the same time, it's kind of, when a manufacturer puts something like this together and they say, do it, it's a little tempting to just say, okay. So, I don't know. I'm still kind of deciding as we film what I'm going to do. And you can certainly take less risk by just going and buying an S-Back. If you are going to buy an S-Back, I saw one the other day, and I'm very partial to Yep. And they just work great. They're very good for the money. And I like them. I had my buddy buy one for his big, it's going to be a $1,500 plane when he's done, Spitfire. And that Spitfire, it's a Hangar 9 Spitfire. I think it's a 1/5 scale, so it's very big. He's going to use, I believe it's a 20 amp, and he can select the different voltage ranges. Now that's the other thing, is you can run a higher voltage on your servos and you'll actually get more torque, and it'll be a little bit faster. Okay? Speed is always generally a good thing because you can always back off the speed in your radio transmitter if you would be going too fast. Alright guys, so for today I have to just separate these things, because here's the thing. One of these is going to run the inboard, and one of these is going to run the outboard, which means that none of these are going to be tied together in the way that they've tied them together. So I have to cut off this heat shrink, and then we're going to be able to renegotiate the wiring. So follow me here. I'll try to explain it as we go. For those of you veterans, this is probably a good video that's going to be played in fast forward. But at any rate, maybe we can learn something from each other. When I say you veterans, I'm no veteran myself. Alright, so the other thing is, these things have no business being tied together in one spot, unless you have a big CG issue. If you have a CG issue, put a bigger battery in there, for God's sake. You know, you're talking about a very small amount of weight here in proportion to the whole overall weight of the vehicle. So that shouldn't be an issue. Now we can cut off our heat shrink. Now if you're going to run this all together, you don't have to cut the stuff off. You can just use it the way that the manufacturer had sent it. And don't worry, this is one of those areas where, you know, it's like, you're going to void your warranty. There's no warranty. Give me a break. This is Hobby King. You're lucky if you get a warranty claim there. It's one thing, you pay a little bit less, but you take all the risk yourself. Go to Horizon Hobby, man. They'll bend over backward to try to help you out if there's an issue. Motion RC, same way. I know there's a lot of other reputable places out there, but Hobby King is not probably the best for warranty stuff. They do occasionally cover warranty stuff, but they'll usually make you send the whole plane back and all sorts of grief. I had Tower Hobbies sort of took care of me on an Arcus that I had problems with, and they sent me one. Had the same problem with the second one. Had to completely reassemble the entire plane. That was a fiasco. But whatever, I ended up getting past it. But sometimes when you get into these projects, especially when you're new, you tend to think, oh well, I saw that guy on YouTube do it, so it's easy. Well, and yeah, you can copy, but what if there's a little bit of a difference in your radio system? So just remember that when you're making your decisions. And there's no better way to learn than to screw up. It's the most expensive way, and you just gotta try to mitigate some of that risk if you're not sure what you're doing, so you don't get somebody hurt. But The best way to learn lessons is the hard way. Well, not the best way, it's the most effective way. Because pain has a way of helping you remember. Anyway, Lessons in Life by Brian, the radio control guy. So once you get all this crap cut off, then you're going to be allowed then to separate all these wires. Now I could leave one of these. I hypothetically could have left one side plugged in. But actually I don't even think I can do that. Because the way this is going to work is I'm basically just going to switch like that, okay? And then like this. Now remember, your black is going to line up to your brown when there's a change in colors. So this is black, red, white, and then brown, red, orange. So orange is equivalent to white, and black is equivalent to brown. Red is always red in this case, okay? That holds true for pretty much everything I've ever worked on in the RC stuff. Okay, so now that being said, let's see if we can't get these things to lay in here halfway decent. It's always a lot harder said than done doing this sort of stuff, because, you know, everything always seems real easy until you go to do it. So, and the other thing is you want to try to do this in such a way that you don't get a bunch of damage. And so I am going to tape the wires for the electronic speed controls out of the way. And I'm going to do it in such a way that I'm careful not to ding up the foam. And I'm careful not to hit my decals. Okay, so just something like this. I've noticed this clear stuff doesn't come off very easy. Some models it will. And if you're really concerned about that, you'll want to kind of be mindful of that as you work. Now those servo lines that you see there, those are the servo lines that are going to go out to the ailerons for us. So we should be able to very easily tell what's what on this plane now for which wires are which, because we've got the red wires are always going to be the far one. But in terms of the orientation, the direction that the motor is going to spin, we don't know any of that stuff yet. Okay. So now you notice I've got this Y cable here, and I took it out and I haven't plugged it back in. Well, I'm not going to be using that. I'm incidentally not going to be using the 2 LiPo configuration right now anyway. I'll come back and test that a little later. For now, we'll just do our testing with 1 pack. I hope I'm not going to kick myself for not doing something more permanent with all this, but this wing section does technically screw together on the bottom through some plates. So I'm going to just double check on the manual before I get too much further. Well, just double checking this, it just shows having 2 screws holding the wing down. So don't see any glue at all. So I think we're good. And I did tell you we'd cover up those wire chases. We'll do that a little later after this glue's set up more. Okay, so now we just need to lay these in here. You know, those servo wires are also going to get in the way, aren't they? These were kind of a pain to get out. But now that I know how it works, not so much. Boy, those little clips, they really made things easy while I was working. So definitely copy that idea, guys. That was a really easy thing to do and made things a lot easier. It's always hard to kind of hold things together temporarily while you're working these projects. Doesn't seem like it would be hard, but it's always more challenging than you think it might be. Okay, so now you can see how those sit in there. We got a capacitor here. The capacitor is going to be prone to warming up, and so is a heat sink. Okay, and then the stuff that's underneath on the heat sinks. So ideally, I'm going to have those going up so they can sink into the air. The other thing is you got to remember this fuselage is going to have air going through it, and it's going to pass over the top of this. So you can try to cut holes in your wing if you want, but I don't think that's necessary. If you really wanted to cut holes, you'd be cutting holes probably right here. Just drill them straight through. and then you'd be doing some sort of an exit strategy for your air, and that would probably go straight down. But you got landing gear you got to avoid, so you could go down right here, would be a safe spot. But don't take my word for it, do some thinking about that on your own. So now the zip ties and stuff, I was thinking about doing some colored zip ties, but now that I sit and look at this, I'm not sure that I want to use these ones. I will be back with some longer black zip ties. Alright guys, so we got a choice of a bigger one like this or some smaller zip ties as well. And I always try to use the smallest thing that I can get in and still get the job done when it comes to airplanes. So I'm going to go with the smaller zip tie first and just fold that. And then what you really need is you need forceps for this step. I can't believe how much I use these forceps. We used them multiple times already in this video series. And I need to actually find some better ones, because the ones I get from Menards are kind of hokey, and I tend to bend them up a little bit in this area, which makes them have slop. So I need to get some better ones. Maybe if I find a really awesome pair, I'll link to them. These things aren't like especially cheap at Menards. I think like $6 or $7 each, or maybe it's for the pair. Either way, I like them so much. I've got, I think, 2 pairs at my shop that the company has. I've got some in my work truck, company work truck, and then I've got my set as well. So it's they're a very valuable tool. I use them constantly, and I mean, for as much as I use them, they're an excellent value. Okay, so we'll just get that mounted, make it look nice and tidy. You know what they say, a tidy airplane is a lot easier to work on, because that's what Brian said. Wait, they don't say that, I say that. Exactly. This thing's going to be so not tidy by the time we're done, I bet. Because it's going to be a lot more going on than I want to admit. Especially if I end up having to separate out the stupid BECs. It's going to be such a pain in the butt. I'm not looking forward to that at all. Although maybe it won't be quite as bad as I think it will be. Basically just interrupt the power wire. That's all I got to do, is just interrupt the power wire. Because the ground wires are already going to be completed at the receiver. Okay, so if you do this right, you can do it in such a way that you'll get a little bit of wiggle room, so if you need to negotiate the wires a little bit to one side or the other. And these won't be here permanently, so it's not such a big deal. But there's a nice little passage there. I might want to keep access to that. I'm going to go ahead and keep these in the same orientation, which might come back to bite me in the butt. So we have a nice day going outside, so it's kind of killing me because I'm torn between continuing this project or kind of wrapping up another project that you guys may be interested in watching, and that is my ASW28. I was going to do a video where I compare the ASW28 to the ASH26, which is no longer available and cost me like $500 and something for the plane. The ASW28, I know as you guys have followed that, I have less than $200 tied up in that, including the servos. But they're both really good planes, and the ASH is better, but it also costs like almost 3 times as much, and you can't buy it. So, but it's nice to do a comparison once in a while between an economy plane and a really high quality plane, especially if they're in the same size class, because it's cool to see the differences, or it's nice to have an appreciation that there is a real difference, but not being sold a bill of goods all the time by the manufacturers. Okay, cool. So that already looks slightly neater. Slightly is the key. Okay, cool. So we got everything in position, pseudo position here. So now at this point, we can choose to do what we're going to do in terms of our connection for power. It's going to be like this. Now you never want to make a condition where these things could touch there. So I think when I decide how I'm going to do this, I'll probably go ahead and just bundle these up together, or I'll bundle them up together up against something, because I just don't want these to be able to be in a short circuit environment. I don't want to have that risk. So I think for now we'll just leave it loose because we're still kind of temping things together. Oops. This ESC doesn't seem like it's very tight. I think it's as good as it's going to get though. Okay, so remember, inboard and outboard are going to be, so there's going to be a pair of inboard or outboard. Now let's look how much cable we got to work with. So the red would be the outboard. So I don't really care which one's which. Doesn't matter to me which one goes to which front or back. So I'm just going to double check if we have any issues for reach. Okay, so I don't think we're going to have any issues for reach there. Now these are marked color for color, but I will believe it when I see them running in the right direction. Yeah, even my supreme-hobbies planes, they come and these things are backward on all the motors. To be honest with you, this thing has actually gone together pretty smooth. It's been a lot of steps, but mostly just because I'm an overthinker, classic overthinker. See, I couldn't even say that without overthinking it. Must have ran out of that color. That's kind of funny. I just don't like tangles. Guys, tangles drive me nuts. Oh, I got that backward. Whoa, that's super loose. You see that, guys? We gotta fix that right now. I'm gonna show you how to. See, that's tight. Tight like a tiger. Alright, so basically, if you run into a situation where you have a loose connector like that, do not move forward. Just immediately fix it. You will forget to fix it, I guarantee you. It'll work until you're flying, and then you'll be screwed is what's going to happen. So I need a really small screwdriver, and then I need an X-Acto knife, and I'll show you how to fix that. This is true for a battery or signal wires or whatever. Okay, see how these things have these little, this thing spins. Okay, so what you're going to do is you're going to get into this little connector. I'm going to try to get it to focus really good for you. Okay, so once you have that, you're going to stick the blade in because my screwdriver is too big, and you're just going to turn your blade, and you're just going to work your way around until you've gone virtually all the way around. I'm just noticing that there's some corrosion on these things too. Now I'm going to go around 180 degrees, and I'm going to continue working these things up. Okay, so just like that. Now watch this, guys. Watch this. This is going to be amazing. Oh yeah, baby. Lots of pressure. So at the end of the day, if you got enough slack, you can tie these so that the cables aren't even going to have any pressure on them at all. And I usually put a little hot glue across there so they can't fall loose. And that being said, these wires for the moment will just kind of stay wherever they sit. So now we'll plug in the black. Man, we're not even going to get the radio set up in this video. That is super frustrating. We're going to try our best, guys, but don't hold your breath. We're almost out of time on this. Notice these colors don't match up exactly. They match up good enough for what I'm doing. But if we find out we're wrong, then we'll have to do something about that shortly. Just do that to hold those in place. We'll just keep them from being an issue, you know, flopping everywhere. It's amazing, just 2 of these clips will hold this whole thing together. The wing sections. Alright guys, since we're coming up on the end of the video, I just want to remind you that we still have some tough decisions to make on how we're going to pull power. So there might be some complexity that I have not actually got figured out yet. I'll try my best to kind of have my game plan together when I come back. I think what we might do in this case is I might go ahead and extend the video a little bit. Try to get these things at least moving so you can see it, because it's kind of cool and gratifying to see the motors finally turning. So when we pause it, we'll get that ready. Alright guys, so we got a 11RX 7-channel with stabilization, vine plugs inserted. We're just going to go ahead and plug in just to make things easy for, you know, make sure we're not going to damage anything. We're going to unplug one ESC. We're going to plug it into the throttle port, okay, so we can get power from the BEC. Then we're going to turn on the radio. Let it come up. System setup, yes. Model select all the way down. Add a new model. Create. Model type, it's going to be an airplane, yes. Model name, and this is where we're going to type in Airbus. I'm going to pause it while I do that. So now you see it says Airbus A380, so we can hit back. Aircraft type, we're going to set it to flaperons. No, we're going to set it to 1 aileron, 1 flap, and the tail's normal. Then we're going to scroll all the way down. We're going to change the picture until we find something we like. I think that's as close as you get on this. And then we have lots of different things we have to set up. Namely throttle cut. So we'll go back to main screen. Okay, we got it on the correct plane. We'll go throttle cut. Turn it on to the switch expected. Okay, so we'll change the throttle cut to 100%. Go and test it in the system monitor. Throttle cut is on, throttle cut's off. It moves. Okay, throttle cut's on. We're safe. Okay, we don't have any landing gear, so we don't have to worry about that. Let's go to system setup. Yes. Channel assign. Gear is gear, but we want gear to be assigned to D. That's the way I always set mine up. Okay. I want auxiliary 3 set up to the right knob, which is what we have set. And I want to disassociate the right and left levers. We're not going to use those right now. Okay. We'll go back in, and then I believe we have to switch gear channel. And then the other thing we're going to do is we're going to go into servo setup. We're going to go to travel on auxiliary 3, turn the knob to the middle. This is where we're actually increasing. This is not an actual output. It's a control circuit for the master gain. Okay, so now we have more range. So we can go back, and I'm pretty sure we have to switch gear. We'll figure it out here in a second. Okay, so we have a battery. This is 3S 2200 screwed up battery. We only have one ESC that's going to be actually energized. or excuse me, not energized, but we only have one ESC that's hooked up to the receiver. Throttle sticks down, throttle cuts on. We're not bound, so I'm going to turn off the receiver. I'm going to press and hold this. I'm going to turn it on. Okay, so now it's bound. Now I'm going to go ahead and power this off as a precautionary measure. Power this off. Unplug the bind plug. Yes, this is precautionary. We have this Metal Gear servo, so I'm going to go ahead and utilize this right now just for... These are the ones I recommend, except I'm not using the digital ones. I'm just using analog. Okay? So I don't know if you guys are familiar with this. If you look at this spec, it says voltage 4.8 through 6 volts, and it says torque 1.6 to 2 kilos per centimeter. This is relative to that, and then this is relative to that. So if you have somewhere in the middle, like 5.5 volts, then you'd be somewhere between 1.6 and 2. In case nobody ever explained that to you. Okay, so we can just toss these away. Those, incidentally, are the cheapest per unit if you buy them in packs of 4. I don't know why. You can buy packs of 10, you can buy 5, you can buy 2, you can buy 1. And typically I would expect that the bulk packaging would be the best way to buy it. Well, in this case, they're actually a little bit more expensive that way. So I get them in, I got 3 orders worth of those. And these are little Metal Gear analog servos, and I love them. They're just super good. So this is going to be our rudder servo. So I'm just going to pop this on here so we can see it move and stuff. And the only reason I care to do that is just because I want some output other than just throttle right now, given the fact that the plane is not completely set up. I don't want to break anything, but I want to see that our receiver's working. Okay. So we're going to go straight into... Where's rudder? There it is. With the orange going up. Okay. Okay, we got a little bit of retention there. Oh, normally we want the radio on first. Sorry, guys. When the RF light comes on, there we go. Okay, cool. So now this rudder moves. You can see we're bound. Throttle cuts off. Bracing myself to see this thing move. Okay. There you go. So you can see that it's acting funny. That's always fun. Throttle cuts off. We have power that's being distributed to all these different devices. We only have one that's commanding throttle channel. Okay, that's always bad. So we're shutting that back to 0. Now we just have to figure out if the ESC is bad or if we've done something wrong. I suspect that we don't know. Okay, throttle cuts off. Okay, I don't like it when stuff like that happens. The thing is getting pretty warm. So I'm going to go ahead and unplug power for a second. These two are being energized. Let's go ahead and eliminate these two from the circuit. None of the rest of the signal wires are hooked up, so we should be totally fine there. We got our transmitter on, and we're going to fire this up. Did you hear it beep that time? This one didn't do anything. So that's always nice. So, not 100% sure what the deal is, but doesn't look to be real great at this point. You notice this one didn't sing, that one did. Let's plug it back in. The BEC is working. go ahead and switch two of our leads. Throttle cut is on, by the way. Okay. Throttle cut's off. No activity other than weird behavior. I've seen this before. That's frustrating. Okay, so what we're going to do is we'll go ahead and detach the power here. Detach the throttle and control signal here. And we're going to go and plug in to this one. Okay. Signal wire up. Then we're going to go ahead and plug in this. Throttle cuts on, throttle sticks down. This is now detached. Okay, so these are not hooked up. Okay, so throttle cut is currently on. This one's warming up. Okay. Throttle cut's off. Okay, good. So that's going the right direction too, which is convenient. So now that we have that one working, we're going to go ahead and de-energize the circuit. Now we're going to plug in this other one at the same time and see if anything comes of it. My guess is it won't. It's probably screwed up somewhere. Okay, as you recall, plugging in the wires to the different ports didn't seem to fix anything, so we're going to go ahead and switch those around back to where they were at the beginning. And then we'll do some more troubleshooting here. Okay, so now we have two BECs feeding this receiver. So throttle cut's on. And this one is not singing still. Throttle cut's off. It's just dancing back and forth. So, what that tells me is that we have an issue. So now I need to start thinking for a second. I'm going to pause it. Before I get too far in my thinking, why don't we just go ahead and hook up the other side of the circuit. I'm going to disconnect power. Okay. So this is going to give me... I don't know which channel I was going to use for that yet, but it's obviously not the ailerons or the elevator. It's not going to be the gear channel. Auxiliary 1 is probably what we're going to use for that. Okay. Because remember the rudder, incidentally, that reminds me, we had that Y cable we took off. That Y cable is going to come in handy because we need to split for our rudder for that thing and our rudder in the back. So we'll have this ready to go. And this is usually kind of how I do this. I'll assemble the electrical circuit as I go. And that way when I see problems, of course it just happens to be that the first one I hooked up had a problem. So that's super annoying. Okay. So now Hobby King's probably going to be like, oh, well, you just send the whole thing back. And I'll be like, yep, you can, never mind, I can't say that on YouTube. Okay, so it's freaking out right now. That's okay. You know why? You know why? because I screwed up. Okay, now we're de-energized. Okay, so I want to go into auxiliary 2. I haven't assigned flap mode yet. It's going to be auxiliary 2, guys. It's going to be on the bind plug. I hope this doesn't cause an issue. Sometimes it doesn't like it when you use the bind plug for motors or ESCs and things like that. So now, watch what I have to do. I have to go into system setup, yes. Channel assign, auxiliary 2 is going to be auxiliary 2, but I need to go to auxiliary 2 and I need to unassign it from that. And I want to set up a mix. Do I have one that's differential thrust? I don't think I have one that's just super easy. I'll just mix it. It's going to be normal. It's going to be throttle to auxiliary 2 with a rate of 100 to 100. Okay. So right now it's just going to not have differential thrust yet, but we'll have to mix that in later, which gets pretty complicated. 100 up and 100 down. So basically whatever the throttle stick is doing. Okay, and it's only going to be mixed. It's only going to be mixed when the throttle cut is off. Okay? So you see how they both move together? But then when I turn that on, this one doesn't go all the way to 0. So that's the other thing we have to work out. And usually what I do is I do a second mix for that. So I go normal. This is going to be throttle to auxiliary 2. Actually, we can just set it to H. We'll just set it to H. So H to aux 2. This mix is only true when switch H is here. So throttle, right now it's already on. So now watch the offsets, what we're going to do. And I don't remember which way it's going to work, so you just kind of have to play with this until you get it right. Okay, see how the aux 2 is going down now? You want it to go back to 0. This would be like 100. See how it jumps up? So now it's tied together. But throttle cut will stop it from doing anything now. Okay? So throttle cut's on. System's going to initiate. All of them are singing except for this retard one over here. Throttle cut's off. We got airflow out of all of them except for the elusive one. Okay, so now Diagnostics 101 is next. This video could take a little bit of time, so I am going to bid thee well for now. So far, we're making progress, just not quite as quick, and this could turn into a bit of a fiasco. So it's probably going to be a new video. We know it's something either the ESC, the wiring, the motor. One of the three, or something mechanical that we didn't notice, like something to bound up. Could just be that the motor is bad. Could be that a wire is disconnected somewhere, or those solder joints aren't good. Could be a solder joint here, which incidentally, let's try that quick. Throttle cut is off. Now it's working. Did you hear it stop? Now it's working. Now it's not. Bad solder joint right there. Guys, sometimes you get lucky. Usually you don't. We have a bad solder joint on this connector or this connector. One or the other or both. Okay? So we're going to fix that right now. And I will pause it while I get that stuff warmed up. Alright, so welcome back to the surgery center here. First step is to cut off this heat shrink so you can see what the heck is going on. I'm kind of leaning toward a cold solder joint. That was the one that we had to fix the stupid plug on. I think I know what's going on. Just a really nasty looking solder joint. I don't know if I trust this connector. I think it might be isolating itself. So what we're going to do is we're just going to desolder that SOB. So what I'm going to do is I'm going to clip onto this. I'm going to stick this somewhere so it can be semi-secure. I'm going to, yes, over my foam. I'm going to desolder and get just a touch. Get a little bit of heat. Let that thing out. Then I can take this little son of a gun in here. I'm not going to throw it away yet, but I probably will ultimately. And I just got to figure out if I can find one that's the same size. And this is why you keep spare parts around, so you can do business with people like Hobby King. Otherwise you'd be constantly broke down. Which is really irritating to me and many other people. Shouldn't have to do this, but we do it because we know it's going to be a gigantic pain in the butt. We'll probably have to take our whole plane apart. Well, that's still a little toasty, I'd say. Okay, let's carry this thing out there. Part number. This is a male and female set. So we'll just see if this fits. This is a simpler style. It doesn't have that spinning ring. Don't need the heat shrink on it first. Okay, so that'll fit that. And that'll fit that. Yeah, baby. Okay, cool. So now we just need to hook this thing up. Put it right there. A little bit of flux. Clean the tip. Of course, I'm right under a fire alarm. I'm good about finding fire alarms to do this stuff next to. Luckily, my family pretty much assumes when the fire alarm goes off that I've done something stupid. Still scares the kids and stuff, so I try to avoid it at some cost. In case you'll notice what I'm doing here now is test for temperature. Make sure I'm not going to burn myself severely. I'm going to grab onto the ring, not the spring-loaded area. Okay, let it cool for a second or two. Oh, I didn't let it cool long enough, dang it! Okay, so now still pretty toasty, pretty toastadelic. Okay, so now what you can do is you can take this, since we've crushed it a little bit in the process of putting it together, and you can open it back up to its natural shape and size. So you get your blade in between that, and you open it up a little bit. And then blammo whammo. So now I'm going to slide this over. I'm not going to heat it up yet until we test it, okay? Then we should be golden. Okay, so let's go ahead and leave that hot. Radio's on, transmitter stick is down for the throttle, throttle cuts on. Go ahead and plug it in. Things initiate. Okay, throttle cuts off. Did I unplug it? Okay. Something did not go exactly to plan there. And I gotta take a look in the menu real quick. Throttle's not moving. Okay, throttle cuts on. I wonder if my battery is dead, and so this thing is not working as a result. We'll just try a different battery. Be on the safe side. Another one that says bad question mark on it. Great idea, me. Let things initiate. Okay. Throttle cuts off. Air, 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 air. Now I'm going to wiggle this. No change. The problem is where we had the problem isolated to. Everything's off. Radio's off. Okay, now we just need to heat shrink this joint in order to get the best crack at success. I'm going to go ahead and heat this up so it's just a little bit over the rim, and then it can get collapsed in the connection. Okay. Well, guys, I hope you don't have that problem, but I bet you will, some of you. I think I remember saying that there was such a high probability of problems with this many connections. And I guess I was correct. I was just hoping that I wouldn't have to be the guy to fix it. Okay, so we're going to let that cool. We'll pause it and go ahead and put the soldering iron away. Okay, guys, well, I'm happy that we got that testing done and we found that one problem and fixed it for now. I think we're out of time on this video for now, so we'll have to pick it up on the next go around. I really appreciate you guys sticking in there. Some of these steps are a little bit tedious, and it's only going to get worse. But it's pretty cool to see these things come together, and the satisfaction you get from actually doing it yourself is even better. So I can't recommend you trying it enough. For now, Brian Phillips signing off. Check the links below. Buy stuff you were going to buy anyway. That's awesome. Help support our channel in that way. Don't forget to click the like button and subscribe. Come back for more. There will be many, many more. And this thing will fly sooner than even I will admit. It's probably going to be pretty cool. It's going to be a sight to see. Be part of it. Thanks for coming.